Hello and welcome to our lesson on important circle proofs. In this lesson, we'll focus on understanding two fundamental circle proofs. Theorem 1 states that the perpendicular line from the center to a chord bisects the chord. Theorem 2 states that the angle subtended by an arc at the center is twice that at the circumference. In our previous lessons, we've covered some essential properties and measurements related to circles. First, we have discussed the technical vocabulary for circles, understanding terms like radius, diameter, chord, arc, and circumference. Second, we have learned how to calculate the circumference using the formula c equals 2 pi r. Third, we have learned how to find the area using the formula a equals pi r squared. With this solid foundation, we are ready to introduce and understand these new circle proofs. These proofs are vital tools in geometry that help us to solve problems involving circles more effectively. Let's get started. Our first theorem states that the perpendicular line from the center to a chord bisects the chord. It's easier to understand what this means with this diagram. Imagine we have this circle with center point O and chord PQ. Imagine we draw a perpendicular line to the chord like this. This theorem tells us that any such line will bisect PQ. That is, PR will equal RQ. Let's now walk through how we prove this. Consider a circle with center O and a chord AB. We will draw a perpendicular line from O to AB that intersects AB at point X. Now we've set the theorem up, let's walk through a step-by-step proof of this theorem. For step 1, draw lines from O to A and O to B. This gives us two triangles, OAX and OBX. The goal of this proof is to show that AX equals BX. To do this, let's start making some observations. First, both triangles share the side OX. Second, OA and OB are both radii of the circle, hence OA equals OB. The next observation to make is that the angles OXA and OXB are both right angles because OX is perpendicular to AB. At this point, recall Pythagoras' theorem, which states for any right-angled triangle, a squared plus b squared equals c squared. Now let's apply this to our two triangles. For triangle OAX, we have ax squared plus ox squared equals oa squared. For triangle OBX, we have bx squared plus ox squared equals ob squared. Since we established that OA equals OB, we can rewrite these equations as follows. Since ox squared occurs on both sides of the equation, we can simplify it as ax squared equals bx squared. Taking the root of both sides of the equation, we have ax equals bx. This is exactly what we wanted to prove. Let's now move on to our next theorem. This states that the angle subtended by an arc at the center is twice that at the circumference. Again, this is easier to understand with a diagram. Let's put 3 points A, B, and D anywhere on the circumference of a circle. We'll go ahead and draw lines AD and AB like this. Let's also label the center of the circle C and draw lines CD and CB. What this theorem tells us is that whenever we have this shape, the angle at DAB, which we will label X, is always half the angle DCB, which we will label 2X. So how do we prove this theorem? Let's go back to our original drawing. We can make the following observations about this shape. First, BC and CD are radii. Second, AB and AD are chords. Let's now connect the points A and C to give two triangles, ADC and ABC. Let's first focus on triangle ADC. We know that CD and AC are radii, so this is an isosceles triangle. Accordingly, angles A and D are equal. So let's label them both as A. Since angles in a triangle add to 180, we can also label C as 180 minus 2A. Let's now look at triangle ABC. Again, BC and AC are radii, so this is also an isosceles triangle. We can therefore label its angles as we did for triangle ADC. This gives the following complete diagram. Let's use this to prove the theorem. The angle around C, made up of the orange and blue angles, is 180 degrees plus 180 degrees minus 2a minus 2b. Let's simplify this as 360 minus 2a minus 2b. Remember that angles around a point add to 360, so we can label the pink angle as 2a plus 2b. We can then simplify this to 2 brackets a plus b. Looking at our full diagram, notice this feature. The angle subtended by an arc at the center is twice that at the circumference. This is precisely what we wanted to prove. In today's lesson, we explored 2 fundamental circle proofs that are essential for geometric problem solving. First, we examined the proof that the perpendicular from the center of a circle to a chord bisects the chord. Next, we investigated the proof that the angle subtended by an arc at the center of a circle is twice the angle subtended at the circumference. These proofs help to enhance your understanding of circle properties. By mastering these proofs, you can more effectively determine segment lengths and angle measures in various circle-related configurations. Keep practicing these concepts to solidify your understanding and improve your problem-solving skills in geometry.